Welcome to another Explainer. Today we're doing something pretty wild. We're unlocking the night shift and exploring the fascinating, completely hidden life of the dreaming brain. You know, most of us just think of sleep as this massive off switch, a time when our minds simply power down for the night, right? Well, actually, scratch that. As the research we're digging into today reveals, your brain is absolutely working the night shift. It's actively processing, healing, and literally reinventing your waking life, while you're just tucked in bed.
So, be honest. Do you think you only dream for a few minutes right before you wake up? It's a super pervasive assumption. I mean, most of us have this illusion that dreams are just these fleeting, totally random little movies that play right as our morning alarm starts going off. But today, we're going to completely shatter that myth. We're going to show you exactly how far your mind actually travels over those 8 hours.
Okay, let's dive into this. Section 1, the architecture of sleep, building the 90-minute cycle. To really understand what our brains are up to, we've got to build our structural foundation first. Sleep isn't just one long, dark block of unconsciousness. It is highly architectural. When you first close your eyes to relax, your visual cortex produces these fast alpha waves. Think of it as essentially turning off the lights in your mind. But as you fall deeper and deeper asleep, those fast waves start to stretch out into much slower, larger amplitude delta waves. Your brain literally shifts its own electrical rhythm.
And it follows a really specific timeline, mapping out what scientists call the ultradian cycle. Basically, it's a 90-minute wave that your brain rides all night long. At 0 minutes, we start at stage 1, which is a light sleep mixed with alpha and slower theta waves. Fast forward 15 minutes, and we hit stage 2. That's when we get these short, energetic bursts of high-frequency activity called spindles. By 45 minutes, we sink all the way down into stage 3, our deepest sleep, totally dominated by those slow delta waves. Then finally, right around the 90-minute mark, we ride the wave all the way back up into REM, or rapid eye movement sleep. Here, your brain activity speeds right back up and looks almost exactly like it does when you're wide awake. At the start of the night, this 90-minute cycle leans super heavily into the deep stage 3 sleep, but as morning gets closer, it favors much longer, pronounced REM periods.
And here is where it gets incredibly cool. The actual stuff going on in your head drastically changes depending on which specific stage of the cycle you happen to be in. In stage 1, dreams are just brief flashes, maybe incorporating your cat meowing or a car driving by outside. By stage 2, dreams become logical, short, and usually feature recent waking life events. Down in stage 3, that deep, slow-wave sleep, we get very simple emotional feelings without any real story. But REM, that's the blockbuster movie. It is immersive, completely bizarre, intensely emotional, and incredibly vivid.
Moving on to Section 2, the REM-only myth. Dreaming is a continuous journey.
So, for a really long time, scientists thought that because REM was so hyperactive, it was the only time we ever dreamed. They literally presumed the brain in deep non-REM sleep was basically a brick, totally incapable of producing any form of cognition, unconsciousness, period. But a massive breakthrough happened in 1962. A researcher named David Falks simply changed the way he asked subjects about their sleep. Instead of asking, "What were you dreaming about?" he broadened it to, "What was going through your mind?" That one simple shift proved that an incredible 70% of subjects recalled mental content from non-REM sleep. It completely shattered the myth that dreaming only happens in REM. It turns out we are thinking, dreaming, and feeling across the entire night.
In fact, modern high-density EEG technology has shown us that dreaming is on a whole continuum. I mean, have you ever been daydreaming at work or school and totally lost your train of thought? Research reveals that instances of what they call local sleep occur when slow delta waves start appearing over the medial prefrontal cortex, even while the rest of your brain is fully awake. This means the part of your brain responsible for directing your thoughts essentially takes a nap while you're going about your day. Dreaming and daytime mind-wandering actually share the exact same neural substrates. It's all connected.
So the crucial point is, Section 3, Dreams as the Memory Machine, the Nightly Librarian.
Why on earth is the brain doing all this? What's the function of this continuous nightly journey? Well, one massive role is that your brain acts like a nightly librarian, meticulously sorting and processing all your memories. We basically have two main types of memory to sort through. First up is declarative memory. These are episodic facts you can consciously recall, like remembering you had toast for breakfast. On the other hand, we have non-declarative memory. These are the unconscious automatic skills, like knowing how to ride a bike without thinking about it. Sleep plays an absolutely crucial role in shaping how our brains store and retrieve both types of these memories, and it takes both non-REM and REM sleep working together to lock them in permanently.
To study exactly how this works, researchers used some seriously fun, relatable tasks. Harvard researcher Robert Stickold ran this famous study where subjects literally just played hours of Tetris. When they finally went to sleep, a whopping 60% of them saw falling blocks in their sleep-onset dreams. In another study, subjects had to navigate this tricky virtual maze. Now, everyone improved after taking a nap, but the subjects who actually dreamed about the maze task improved 10 times more than the ones who didn't. When daytime tasks infiltrate our sleep, our waking performance gets a massive upgrade.
But here's the catch, and it's a big one. The brain isn't just hitting replay on a Luke. It's creatively mutating the memories. Take a look at this actual dream report from that maze study. The dreamer literally said, "I can see the maze, and I think if we could swim above it, we could see everything." Swimming above a maze? The brain is taking this rigid waking task and exploring totally abstract creative solutions to it while asleep.
And this brilliantly illustrates just how active this offline learning can be. Researchers tested this exact thing with lucid dreamers, people who can consciously control their dream content. They asked them to intentionally practice throwing darts in their dreams. Those who successfully practiced the task in their lucid dream actually threw the darts with much better skill in real waking life the very next morning. But remarkably, the ones who got distracted in the dream, like trying to use a mirror as a dartboard or something silly, actually threw worse the next day. The dream content itself is directly critical to the learning process.
Section 4. The hyperassociative brain, recombining the past.
This brings us to another completely wild function of our sleep architecture, specifically during REM sleep. REM acts as this hyperassociative web. It takes those stabilized memories and links them together in incredibly novel ways. Let's break down how our brains integrate new experiences into long-term holistic knowledge. Step 1. You encode a specific episode. Let's say drinking a latte at a brand new cafe. Step 2. As that memory transfers to long-term storage, the context separates. The specific time and place totally decouple from the general features, like the fact that it was sunny or that you were reading a good book. Step 3. During REM sleep, these little fragments recombine with other overlapping memories from your entire past. This Hebbian process actually strengthens the associations between these fragments, allowing you to build a general holistic understanding of the world, rather than just keeping a massive unorganized stack of daily episodes in your head.
Because REM sleep has such high levels of activation all throughout the cortex, it gives you access to incredibly remote memories. Think about a distantly related word puzzle. You have to find the link between the words falling, actor, and dust. Got it? The answer is star, falling star, movie star, stardust. Well, research shows that if you wake someone up directly from REM sleep, they can solve distantly related word puzzles exactly like this one, way faster than if they were just normally awake. REM sleep literally increases your brain's ability to access distantly related concepts. It's like a superpower.
We can even trace this memory integration happening on a timeline, watching it morph week by week in what scientists call the dream lag effect. On day 1, a recent memory shows up in your dream as day residue. It's a fairly literal point-by-point replay of an event. But then the memory usually vanishes entirely, only to reappear in your dreams around day 5 through 7. But this time, it's not literal at all. It's a metaphorical integration. There was the sleep study subject who worked as an EMT. He treated a pretty bad baseball injury on day 1 and dreamed literally about a baseball injury that night. But a week later, that same memory source resurfaced. Only this time, he was dreaming about walking home from a golf course and getting sidetracked playing a friendly game of baseball with his friends. The memory morphs, you see. It becomes less direct and merges with much more distant knowledge over time.
Which brings us to Section 5. Overnight Emotional Therapy. The therapist is in. Finally, let's look at what is probably the most emotionally powerful thing your sleeping brain does. The big mantra among dream scientists is that dreaming is a literal form of overnight therapy. Sleep is uniquely designed to process our traumas and our heavy emotions. To prove this, researchers conducted a highly relatable and honestly kind of hilarious study. They had participants sing along to karaoke videos wearing headphones. Then later, while the subjects were trapped inside an fMRI brain scanner, the researchers played back the raw a cappella recordings of their own out-of-tune singing. As you can imagine, this induced immense self-conscious distress. Their amygdalas, which are the emotion centers of the brain, lit up like fireworks with shame and embarrassment.
Now, what's really interesting about this slide is what happens the very next day. It perfectly proves a model called sleep to forget, sleep to remember. During that initial embarrassment in the scanner, amygdala reactivity was off the charts, high as can be. But after a night of uninterrupted REM sleep, that reactivity plummeted dramatically.
The brain actively stripped the painful distress completely away from the memory. Importantly, though, if the researchers woke them up and disrupted their REM sleep, this emotional healing benefit was totally lost. You absolutely require REM sleep to dissipate emotional arousal over time. It leaves us with the memory of the event, sure, but without all that crippling emotional weight dragging us down.
Which leaves us with this final, really profound thought to chew on. We spend a third of our entire lives asleep, largely just ignoring what happens in the dark. But if our dreams are up there, acting as our nightly librarian, quietly rewriting our memories, linking our distant creative thoughts together, and actually healing our emotional traumas every single night, who are we without them? Your waking mind is really just one half of the story. The person you are today was forged in a massive way by the unseen work of your dreaming brain last night. Thanks for joining me for this explainer, and seriously, I hope you sleep really well tonight.